It is 7 o'clock, so that means it's time for Model Monday. We can get started picking up on our project that we've been working on for the last couple weeks, which is our automatic window blinds. So, for those of you following along at home or here in person, this is where we stand right now. We have got a couple of gears. Oh yeah, we can turn off lights, or we can. Does it? They don't dim. You can turn one of them off at a time. I just have to do the app thing real quick. So let me just because for ease we have to use it. We have to scan a QR code in order to turn the lights on and off here at the makerspace, which makes sense. There we go. Does that work?
No, it's the opposite way around.
Are you sure? I'm pretty sure. We don't want this row on, right?
Right.
We want that row on.
Okay.
Right? Cool.
We're fine without any.
All right. All right, cool. So, like I was saying, so far we've got a couple of gears drawn. We've got a large gear that's going to thread onto our rod that controls the adjustment. You can twist it and it opens and closes. We've got a small gear that you see right on there that attaches to our motor, and we've got our motor. And just a teaser, this is actually what we're making today. So our little bent piece here, which I've made out of plastic, but probably should get made out of a nice piece of sheet metal. This is what we're going to be making today. So without further ado, let's go ahead and jump into it. So I've got my document open here, and I'm going to start by creating a new component in this document. So I've got my document nicely organized so far. We've got a component that is our drivetrain. There we go. It's got all of our gears and our motor in it. And we've got our main document component here. I've got my main document component as the active component. And you can see that that is true because I've got the little radio button next to the component active, just for the sake of illustration. Now the drivetrain is my active component, but I do indeed want my main document component to be my active component, because when I say create and then new component, it'll be easy to create that component inside of my document component here. So we got our new component window here, and I'm going to go ahead and name this. This is going to be, I guess, the bracket, or the mount, I guess would also be, or the
Mounting bracket.
mounting bracket. Mounting bracket. I like it. All right, we're making it a new component here, and you know what? I'm going to choose to make this a sheet metal component right off the bat, because the only thing we're going to do here is make sheet metal. So I'm going to choose to, instead of making this a standard component, I'm going to go ahead and make it a sheet metal component. And I'm going to go ahead and say OK. Well, if it's not a sheet metal component, you're totally fine. It's not necessary, but it is an option. And gosh, I wonder if there is a way to. I'm not sure if there is a way to change the type of component after you create it.
Start a new component again.
If I say properties, no.
Yep.
Yeah, I don't think there's a way to change the component. Create drawing, yeah, I don't believe so. All right. And once you've got that component created, we can spin that component open. And we can see we've got our sheet metal component here. It's got an origin and everything went ghosted out. Everything is kind of transparent looking. And that's because it's made our mounting bracket component our active component. And we don't have anything in this component right now. So right now everything is ghosted out. It only shows you things as being solid when they are in the component that is active. If that makes sense. So let's go ahead and start by creating a sketch. I'm going to go ahead and from my create menu, I'm going to go ahead and choose the create sketch option. And I'm going to go ahead and I'm going to create this sketch on the face that represents the face of my motor. So I've got that little stepper motor there, and it's got a big face right on the front of it. The side that has our motor shaft on. And I'm going to choose that as the face that I'm going to pick.
Okay. What do you do if that surface won't select?
You may have
make
to
something visible.
You may have to kind of zoom into it a little bit. So
Here's what we got. Okay. I'm zooming in and
see it there at all.
exactly.
Well,
Well, you can see the.
in your drivetrain component. You spin down the little.
Sketches.
I see your gear. And then is that the? Which one is that? I don't see your motor at all. Oh, there it is.
Okay, that's it.
Yeah, there you go. I think you've got. Oh, just
Okay,
maybe it's the create sketch.
create sketch. Okay, now so I was a step behind.
And
Yeah.
then you'll just have to click on the face of that motor. There you go. There we go.
Capture
Okay.
or
Good.
capture or revert component positions.
Oh, I would always say capture.
Okay. There we go.
All right, cool. So now a lot of this sketch I want to make using existing geometry. So the mounting holes for our motor, we're going to need to mount our motor to this piece that we're making. There's going to need to be a hole for the motor shaft and a hole for where the control rod can go through here. And as you may know, we can use the project command to go ahead and grab some of that existing geometry. So I'm going to click on the create menu and I'm going to go down and find the project include option. And I'm going to come over to project. All right. So, like I said, there are several things that we want to project here. We want to make sure we include the motor mounts. So these openings on either side of the motor, if I hover over just the interior section there. So here I'm selecting the whole motor. I just want to select the interior ring or the interior opening of each side of that. I'd like to select the center point of our control rod. So I don't need to select the edges of this control rod because I think I'm just going to make this a circle. In fact, I know I'm going to make it just a circle. So I'm going to project the center point that I can see highlighted here. If for some reason you can't see a center point highlighted, it could be that I have that sketch active. So if we find the sketch, it would be this 10 tooth gear. If you can't see that center point, you can make sure that your sketch inside of your helical gear 10 tooth is visible. So I just went and toggled that on so it's much easier for me to see and project over that center point. And then the fourth and final thing that we want to project over from existing geometry is the shaft of our, or the opening for the shaft of our motor. So it's this circle, this widest circle on the other side of this gear. And in order to actually click on it, because it's the other side of this gear, I have to turn off the visibility on that particular gear or on that whole component. You can do that if you wanted to, in order to click on this outer ring so I can actually see it. Just with the little eyeball next to the component, so I can turn off my whole drivetrain component if I want to, and that turns off the visibility on all those things. So I can see I've got the 4 items or 4 objects selected here in my in the geometry section of my project window. And I can go ahead and say okay. All right, now we're going to go ahead and kind of round this out. So we've got kind of the openings that we want to have in our sheet metal piece here, modeled almost, with the exception of our circle that that the control rod is going to go through. I went over the top here. I bought little bearings that go inside of that ring here that we're about to draw. Little tiny bearings, and you probably don't need them. If it's plastic, you definitely don't need them. But I bought them, so I put them in. And you will definitely need a circle drawn at the same center point as that center hexagon, or center polygon there, rather. And your circle will need to be, so I'm going to go ahead and grab from my create menu, I'll go ahead and grab the circle center diameter circle option. And at minimum, the circle that you create at the same center point that we projected over from the center of our center polygon there will need to be as wide as the outer flat part of our polygon, if that makes sense. So 0.325 seems like a good amount there. Whatever is the widest part of your, actually that's not true, it has to be the widest part of our polygon, so it needs to be 0.375. 0.375 is good, and that'll just rest on those outer edges. You don't want it to bind up. We don't want our control rod to catch on the edges of this, or to be stopped by the edges of this as it's rotating, but we do want to help keep that centered, if that makes sense. So we need something to hold it in place and keep it from moving away. And if you're putting a bearing in, I have these little bearings, and they are 15 millimeter outer diameter, So that is the circle you would need there. So again, mine have these bearings, so I'm going to put them at the 15 millimeters outer diameter there. Bless you. And that way, this little bearing I got, again, kind of overkill, but bearings are pretty cheap, so. All right, 15 millimeters is my bearing size there. And now we need to kind of create, now that we've got all the openings that our sheet metal is going to have, we need to have kind of an outer area, right? So an outer edge. I'm going to create that outer edge by doing a couple of offsets. So I'd like to have a little bit of gap, some sort of distance between the openings of my sheet metal and the outer edge. So I'll create that outer edge by specifying those distances, those offsets that I want. So from the Modify menu, if I go ahead and choose the Offset option, and if I choose that 15 millimeter circle that I just made as the sketch curve that I want to offset, or create an offset from, now I've got this little blue triangle, and I can just specify a thickness that I need to have around that opening. And the thickness that I chose for this was about 1/4 of an inch, which seems like a decent little offset there. And I'm going to hit enter. I'm going to do that same thing for these small openings that I have here. So the openings that my motor mounts into, I'd like to have a safety offset outside of that, just so there's enough meat for my motor to grab onto. So the same way that I made that first offset, if I choose from the Modify menu the Offset option, and I think, nope, it'll only let me do one at a time. I was going to say you can do more than one at once, but I'm going to choose to make this 1/4 of an inch as well. So again, 0.25 inches, and that'll be how much space I have between the cutout and my outer edge of my wall there. And I'll say OK. I'll do that one last time for my other opening here. So from the Modify menu, I'll go ahead and choose Offset. It's also the O key on your keyboard in case you want to impress your friends and start spouting off keyboard shortcuts next time you're having a Fusion 360 party. I'm pretty sure that's what the kids do now, right? It's like Fusion 360 parties, all right? All right, so the last thing that we need to do here is connect some dots, and then we'll have our outside edge. From the Create menu, I can choose my line tool, and I'll show you a couple ways to do this. So I'd like to create a line that is tangent to both of these circles, to my large circle and each of my small circles. And there's a couple of ways we can do this. So I'll intentionally do the first one kind of poorly. So I'll just kind of hover and connect my lines to the circles in a way that is not tangent at all. And then I can add my tangency after the fact. So here I've got a line that is connected to these circles, it's not tangent. And to add that constraint after the fact, I can come up here to the Constraints menu, and I can choose this Tangent option, and I can specify the circle and the line that I want to be tangent to each other. Failed to solve. Please try revising. That's interesting. Oh, there we go. Worked that time. The tangent constraint is the one that's a circle with a line that kind of run next to it.
Okay,
It's the third from the top.
got it.
And if you click on the line first and then the circle second, in theory it should work. And then I get these little tangent constraint icons that pop up there. Another way to do this would be to draw it right from the start, draw it right the first time. So if I grab my line tool again, there is a magical, actually it's easy to make your line tangent to the second circle, kind of just by chance. If I just hover my mouse over what appears to be tangent, then I get one of those tangents for free. So the first, I just clicked on the circle. The first point, I just clicked on the circle. And the second one, I can hover over it and get close, and then I get that tangency for free. And then I have to add, after the fact, that tangent constraint. The third and final way to do this is if you happen to know that you hold down the, if I hold down the shift key before I click anything, and now I click on my point where I want to create something on the circle. Oh, is it shift or is it control? I thought it was shift. Oh, there we go. So here, if I'm holding down the shift key, now you can see that it is forcing that tangency to the first circle while I continue to hold down the shift key. And I can move it over and hover over where about tangent looks. And then I get those two tangents. Again, just holding down the shift key the whole time I was clicking there. So, two ways to do that. More than one way to skin a cat. More than one way to click something in Fusion here. We're almost done here. I think I'd like to do one last thing here with this drawing, and that is we're going to make our flange kind of come up the back of this thing here, and it's just a little neater if the flanges have don't have circles that are involved right next to them. It'll just be easier to cut out after the fact. So I'm going to go ahead and grab my line tool, and I'm going to draw my lines from my sides kind of off the edge here, if that makes sense. So I can click on the end point of that line, and you can see I'm hovering so I get that little two blue line options there. Those are my parallel constraints. So it's telling me that this line I'm making is parallel to this line over here. And I just want to draw out a nice corner on my little base plate here, or what will eventually be my base plate. And then I'll kind of do a little check-in, see how you guys are doing. No? We're doing bad? Let me take a little walk around the room. Robert, how you doing?
I'm just following along.
Cool. All right.
This is what happened when I did the project.
I'm going to take a little pause here and walk around the class here.
This is my result from projecting points. So at this point,
So it looks like we had the wrong plane selected. Yeah.
I tried spinning around. So sometimes you're just wrapped up.
Okay, all right. How are you doing?
Well, I only got figured out how to get two selected. This went somewhere in the background.
Okay.
And consequently, I just stopped and observed.
Okay, cool. Is that where you want to be right now? Stop and observe, or you want me to?
No, I'll just observe. Let it keep going for the sake of everybody at home, and
See, this is
I'll screen this.
bringing back the gears and the motors, this is what it looks like.
Okay.
Yeah. So I think you're in the right territory. It's just if you click finish sketch, and then you can probably just delete that sketch. There you go. And now,
It's,
okay, right.
I'll observe.
All right, cool. All right.
Thank you for trying.
Sure, no,
Sometimes
yeah.
it's a hopeless cause.
No, nothing is ever hopeless. I'm happy to pause and give assistance for sure. It's the benefit of coming to class is I can pause and give you guys assistance. So, all right, cool. So, this is the shape that we're looking to get here. Is kind of this like weird triangle, I guess you could say. And now I'm going to go ahead and say finish sketch. So I've got a sketches folder now here inside of my sheet metal component, and I'm going to go ahead and name that. This is going to be my motor mount. Like any name is better than sketch one. Any name is getting to a better place than sketch one. So, all right. So now you would think we'd want to extrude a thing, but actually, because we're in the sheet metal, we're going to live in sheet metal land for a second here. We're going to leave the comfort of our solid workspace. We're going to bounce over a couple of workspaces to the great and mysterious sheet metal workspace, where everything is a flange. And it's kind of interesting. Like literally, this flange command does just about everything that we will ever need here when you're creating a sheet metal part. I don't know how that's the case, but that's how they made it. So when you want to extrude out your sheet metal piece, we use the flange command. So I'm going to go ahead and choose this flange command from the create menu in the sheet metal workspace. I'm going to click all the little kibbles and bits of my sketch here. I suppose the appropriate way that I should have done some of this is I should have made these construction lines, but that's okay. We'll just click on all the kibbles and bits. There we go. That's what we're looking for. And something that you will notice is we've got a thickness here, but we didn't specify a extrusion amount, right? And that is because it is using, if I go ahead and say OK, the thickness that this material, that this piece of metal is determined by rules. So in this sheet metal component has a rule here that says if I click on the little icon next to the rule steel and millimeters, yours might say something different, but I'm using the steel millimeter rule. If I wanted to, I could change that to 18 gauge steel and say OK, and it goes ahead and changes the thickness of that piece of sheet metal there. 18 gauge sheet metal is probably not a thing that comes standard with Fusion. It's probably something that I added. And if you ever need to, or you will probably need to, change or add new sheet metal rules if you get into this. So, like for example, this is not metal at all. This is plastic. We've done things in the past where we make cardboard out of sheet metal stuff. So you may need to make a sheet metal rule that is custom. So in the modify menu, you can choose the sheet metal rules option. And here we've got our sheet metal rules window. So these are all of the sheet metal options that are either given to you or you have made yourself. And any of these, if I want to say, hey, this aluminum here, I want to make another aluminum sheet metal option, so I can just hover over aluminum inch, Or here, I've got one called plastic, but here, we can do that. I'll click on the little icon that says new rule. I'll give my rule a name. So this is going to be my 0.12 for, this is going to be plastic. This is going to be plastic 0.125, an eighth of an inch. And I'll change the thickness here to be an eighth of an inch. And in general, our K factor, the K factor is like the amount of stretch that a material will give. And in general, it's about half of the thickness of the material. Things that bend, roughly half of the thickness of the material. So 0.0625, that is the amount of bend that I will get out of the material here. And I'm just going to say save. And now I've got that new rule, plastic 0.25 inch, that I can now call out over here in my rule for this component. So I'll just click on the little icon that is the rule for this component, change it over to that eighth of an inch thick plastic, and there we go. Now we can hide that sketch. I'm gonna turn this so it's right side up, because this is actually the top of our sketch here, and we can create the rest of the shape here. So from the create menu, if I choose the flange command again, this time instead of selecting a sketch, I'm going to select an edge. If I select an edge of a piece of sheet metal, I get this little arrow, and now I can just drag this straight up, and we can see here that I'm kind of cutting off my my gear here. So I just have to change this bend position. Oh, I'm gonna have to modify my sketch. That's okay. So I'm going to change that bend position to outside, and I'm going to extend it up the length that it needs to be, which is 6 inches. Now, this is the length that mine needed to be, because for some reason near the top of my little control rod there's a little nub, so I can't move this gear up all the way, if that makes sense, because it's stopped by a little nub. I'd like it if I could get it as close to the top as possible, but I need like 6 inches of gap, and this will probably vary depending on how your window blinds are installed. So you'll have to be conscious of this number, but 6 inches was a good number for me. And I'm going to say OK. And now I'm going to add one more flange before I go and fix the problem that I've got going on. So the problem that I have is my gear is clearly running into my sheet metal piece here. So before I fix that, I'm going to add the one last flange that I need, which is up here at the top. So from the create menu, I'm going to go ahead and choose the flange command one more time. I'm going to click on one of these top edges here. So I'm clicking on the edge that is on the side of the direction that I want to bend in. So that'll give me a bend that goes off in that direction. If for some reason I wanted to bend in the other direction, I would click on the opposite edge. So this edge lets me bend off in this way. It won't let me bend away from itself. You can only bend in the direction, and I suppose this would work too. I suppose it depends on how your windows are hung, but I think for me it worked out best to bend in the other way. and we just need to go 1 inch. Because I'm attaching this to the kind of the upper wall with a little like 3M command strip, one of those little hook and loop things, that holds it up nicely, and they're just about 1 inch thick. So make that 1 inch, and I'll say OK. All right, now let's talk about fixing our little issue. So our gear runs into our wall, and in order to fix that issue, I'm going to go back to this sketch that we made. So the sketch we made at the very beginning of this component, if I right click on this sketch down here in my timeline, or I right click on the sketch in my sketches folder and say edit sketch, now I go back in time to when I was creating this sketch. And something I can do here is probably the easiest thing would be to change the size of this offset. So if I make this 0.325, then that gives me just enough room there for my gear to turn around. And now if I say finish sketch, oh, that's interesting. So I said finish sketch, and clearly something has went wrong here. So I'm going to go back to that very first flange that I made and choose to edit that feature. And for some reason it's lost a couple of these profiles here. So I'm just going to go back in. Oh, that's not long enough anymore. Look at that. So what happened is I made my circles longer, and this line over here, these clearly extend out long enough to meet with each other. These do not. So I gotta drag out this line so it's, you know, it makes an enclosed area out of that. And now it didn't even need any extra help making that. It had it all good to go. So now our gear just barely... Oh, you know what? We're going to need a little bit more because it's got a radius down here. So let's do that one more time. In fact, instead of changing that, I'm going to make that 1/4 of an inch again. I'm going to make this 1/4 of an inch again. And I'm just going to add a rectangle. So from the Create menu, I'll go ahead and choose Rectangle, and then 2-point rectangle. And I'll make that the first point of my rectangle. And then I'll just make it, I'll hit the Tab key. Yeah, like a 1/2 inch. 1/4 of an inch might be sufficient. I'm going to try 1/4 of an inch. Because now that we have a number here, this will be easy to update later. I've got a blue line over here because I didn't specify a distance or a dimension for this upper line. So this blue line is not fully constrained. And I think I'm going to let that fly for now. I suppose the constraint that I could add if I wanted to fully constrain this sketch is I could choose this coincident constraint. And I could always make sure that that line is coincident to that point, which fully constrained it. And that's probably a good way to do that. Let's test it. Because now if I change this measurement, kind of. That worked pretty good. That worked pretty good. All right, we'll roll with that. All right, so now my flanges are definitely going to break. And that is because if I click finish sketch here, oh, they didn't break. It just didn't select the right thing. So I have to go back and edit each one of my flanges probably. So this first flange that I made, if I right click on it and say edit feature, I gotta add in that rectangle that I made out the back, right? And say okay. Now it broke. And that is because this edge did not exist previously. So I'll have to go and kind of work systematically. And sometimes when I do something like this, when I go back and change something fundamental, I'll take my playhead right down here at the bottom and I'll just drag it back in time and work step by step. So here my sketch is made. That looks good. First flange looks good, right? I added those little bits. Let's go one more flange up. Something clearly went wrong there. So if I right click on that and say edit feature, the thing that has gone wrong is there's nothing here in the window. There's nothing clicked on. So if I specify that edge, now it remembers everything. It goes, oh yeah, the 6-inch thing. Let's go ahead and do that to that edge. And I'll say okay. And now if I drag one more step over, you know, it didn't do the last because, you know, this edge is different, I guess. And I'll just do the same thing, right click and say edit feature. And then I will pick that line that I picked initially and I'll say okay. All right, cool. So the whole reason that we were doing this as a sheet metal component is because Fusion will let you do something with a sheet metal component that you can't do with another body type, and that is to unfold it. So we've got a bent piece here and we want to actually make it physically. If you're going to send this to a manufacturer or you're going to try to cut it out on a laser here at the makerspace, you'll need to unfold it and give them a DXF file. So let me show you how that works. From the create menu, you can choose the create flat pattern option. So if I choose this create flat pattern option there, and I pick a face of my model that everything is going to unfold around, you kind of have to pick a face that's going to be stationary, and then everything folds down to that face. If I choose that back piece as my stationary face and say OK, now it unfolds it and makes it a nice flat piece, which is fantastic. So this works for more complicated items too. If you've got a box that you're folding up, where you're folding up all 4 sides, right? It'll unfold it nice and flat. And that's what we've used sheet metal in the past for this class for, is we made custom boxes for all of our Christmas presents one year. Or at least I did. I don't know if everybody in class did, but I mean, it would have been cool if they did. All right, so now we've got our flat pattern here, and there is an option now here at the top that says export, and you can export your flat pattern as a DXF. I don't convert my splines to polylines, and I don't know why you would. Also, I don't think there are any splines in this model. They're all regular curves. Spline is those weird shaped curve things, and a polyline is a series of flat lines that kind of look like a curve. So a polyline is not curves, it is flat surfaces that resemble a curve because they're small and they're short enough little flat lines. But we don't need to do that. Like I said, I'm not sure when you would need to do that, but I've never had to. And I'll say OK, and then you can just name your file. This is our bracket mount bracket. Is that what we decided to call it?
Mounting bracket, that's what it was called.
Mounting bracket. Mounting bracket, flat pattern. Put it in the place where you can find it on your computer, on your confuser. And there we go. So that DXF is the thing that I would cut right out on the laser. You can import that right into our laser here, and you can start shooting laser beams at stuff. And that's how I cut out these pieces. You can also, I'm just going to go ahead and say finish flat pattern here. You can also take that DXF file, and any place that will do laser cutting for you will accept a DXF file. And just for example, I have used in the past send, cut, send. And this is a pretty great service. If you'd like to have a piece cut out of metal instead of plastic, they have water jetting services, and they have laser cutting services that will cut out metal pieces, and they'll do the bending for you too, which is pretty cool. So here, I suppose I should be sharing this on this screen so everybody here in class can see it. So you send, cut, send. We'll make these little metal pieces for you, and they'll just take a DXF file and make magic happen for you. So they'll even tap holes, which would be cool, because then for mounting our motor, we wouldn't need a nut. You could just tap this piece, and then you wouldn't need a nut. Saving on parts. All right, so the last thing that I want to do here with the remainder of the last 10 minutes of class here is, if you do want to bend this yourself, you're probably going to need the help of some tooling of some sort. So I made some little pieces that I can clamp. I can heat up my plastic and then clamp it, and I've got like a little jig that pinches the pinches the plastic into a bent shape. And these are just 3D printed bits. And in order to make these, I'm gonna make another component. I'm gonna make this component inside of my sheet metal component though, because I guess it's all part of the bracket, or at least it's part of the bracket design, I guess you could say. So I'm gonna leave my mounting bracket, my active component. I'll go ahead and say create, and I'll create a new component, and that new component will be called my bend form, or maybe this would be called a buck. My bending buck. Maybe somebody can leave a comment if I'm using the wrong terminology here. But if I make that bend component, oh, it wants to make it a sheet metal component. That's interesting. I wonder if that's because I can only have sheet metal components inside of sheet metal components. Let's try this again. Or because I just didn't choose standard there. Bend buck. Okay, cool. I just forgot to pick standard as the component type. So now I'm going to use the same tricks that we've just used. So I'm going to create a sketch. I'm going to create my sketch on the side of this sheet metal component here, on like kind of that edge. So if I choose create and then create sketch, and I zoom in here so I can click on the side of that. And now what I want to do is project over some geometry that already exists, right? So from the create menu, I'll go ahead and choose the Project Include option and then over to Project. This time, instead of choosing a selection filter that is specified entities, I'm going to choose an entire body to project over. And now I can either click on the body in my drawing view, or I can spin open the bodies folder in my mounting bracket sheet metal component and click on the body in my browser there. That'll work just the same. Now I've got those projected lines that have come over here, and now I can just create a nice little rectangle here. So from my create menu, I'll go ahead and choose rectangle, and then two-part rectangle. I'll click somewhere out here to place the first point, and then I'll line up the second point with the edge of my sheet metal bend there, and I'll click and place that second point. And now I'll just say finish sketch, because now I've got two pieces that are separated by the thickness of my sheet metal there and that bend radius. I'll go ahead and I'll name that sketch. This is my bending form. And now I can just extrude both sides of that. Instead of extruding them a distance, instead of extruding them that type of distance, I'll just extrude them to an object. And the object that I'll pick is the, I'm going to zoom in here, pick on that face. And then it will make it exactly the same thickness as my sheet metal piece. I'm making a new body, and I'll just say OK. So that is it. Now we've got two bodies here that we can name. We'll just call this the inside, and I'll call this the outside. And now I've got two pieces that I can print out, and they'll help me make these bends if you want to make them yourself. So it'll help get you a nice square, fairly regular looking bends. All right, cool. So that is it. Let's go ahead and I'm going to turn off that. I'll make my main document component my active component again. I suppose for good measure here, my gears are kind of like inside of this sheet metal piece. They're not up high enough, so I'm going to go ahead and move them up just use the move command, and I'll pick a, whenever I do this, whenever I'm moving a component around, I want to move this entire component. I don't want to just move the body inside of this component. Does that make sense? So a component is sketches and bodies and construction planes and joints are all inside of a component. So in fact, I bet it won't even let me move. If I just try to move a body, oh, it'll let me move it. But if I want to move a body or a component that is just one body, I always choose to move the entire component. Just because it makes more sense to move everything that's associated with that in my head. So I'm going to go ahead and do... Fusion's has an update. And now it's being a little squirrely for me. So I'm going to move both of those gears up. So they're just kind of off the top of the surface there. And in theory, because I chose to move the whole component, it's not going to break our gear here. Yeah, it didn't break our joint. So our joint still works there. All right, cool. So, you know, the next part of this would be designing the electronics. Does that interest you guys who are present? Or you at home, Robert?
No, I'm following along.
Okay, cool. But like, if the next step is we would like do the electronics of this, and we jump over to like the PCB end of Fusion 360 and do an electronics layout, like making our own custom PCB board. Does that interest you, or would you guys rather see moving on to a different project?
I prefer to move on.
Mike, do you have a
Yeah.
moving on? Robert, you've been outvoted. I don't know if you had an opinion anyway, but
Yeah, but I have a totally different question.
sure.
When you made the two parts, which were like a mold, you know, to bend the plastic, is that the concept that they would use like for injection molding or die casting, where you draw whatever part you want and then you make the surrounding tool that would fit on it? Is that what they do?
You could certainly use that as, yeah, depends on your part. So,
Like your gear, let's say it's gonna be made out of plastic or injected aluminum.
yeah,
Could you make the mating parts of that, which would basically be the design of the mold?
yeah. Tell you what, I bet I can do that in just a couple minutes here. Let me kind of show
Oh, we
you.
have 2 minutes left.
Well, that's all right. So, I'll go to my drivetrain component. So Robert was saying, like, hey, if we wanted to make a mold of something that we've got here, you know, just like I made this. Let me make this my active component. Just like we made this form, is that the same method that I would use to make like a mold of a part, right? And he suggested, like, hey, we've got these gears here. What if we wanted to make a mold of one of these gears? So let's do that. If you right click on a component, you can choose an option that says isolate here. And this is really handy. So like I really want to just look at the gear. I don't want to look at all the other stuff. And I don't want to go through and turn off each one of my 27 different components that I've got going on. If I choose that isolate option, it'll narrow us down to just that one object. So that's a kind of a pro tip here. I'll make this my active component, and I'll create a sketch. So I'll create a sketch right on the top surface of that gear. I'll say capture position, sure. And I'm just going to make a circle. I'll make a circle that makes sure it encompasses the entirety of our gear here. So I go outside of the bounds of that gear. And then I'll just say finish sketch. So now I got to find that sketch, which is going to be here inside of my sketches folder in that component. Yeah, so sketch 4, this is going to be our mold. And I'm just going to go ahead and extrude out that circle, all parts of it. And I'm going to choose to do this instead of on one side. I'm going to go ahead and choose to do it 2 sides. And one of the sides, I'll go out as to the surface of the gear. And the other side, I'll go out, I don't know, 1/4 of an inch or a little more than 1/4 of an inch or so. So, and let me choose to, instead of making this a cut, we're going to make this a new body. So what I've kind of got going on here is I've got my gear that is, let me see if I can highlight that gear. my gear is nested inside of this cylinder. If I turn off the gear, the cylinder still is there. So now what I can do is I can use the gear, the body that is the gear, to cut away from our cylinder. So I'll go back to my solid workspace here, and kind of counterintuitively, Robert, I'm going to use the combine tool in order to subtract. So if I choose this from the modify menu, the combine option, let's see, where is it? There it is, combine. The target body is going to be the cylinder. So the thing I want to do the subtracting from is going to be my cylinder. And the tool that I'm going to use to do the subtracting is going to be that gear on the inside. And then I just have to change my operation here from join to cut. And now I'm going to choose to keep the tool. So normally if this was unchecked, the body that is your tool would disappear from your browser over here. But I want to keep that, so I'm just going to say keep and then OK. And now, if I... Did I... Hold on, let me make a slight adjustment to my extrusion here. I'm going to go just a little bit less than my gear thickness. So I think what was happening is, there we go. Now, there is my gear. And basically we've got a gear mold, right? Now I will say that, like, for vacuum forming or like injection molding, you really got to have what is known as a draft angle. So when you pour something or inject something into this mold, all of these walls kind of go straight up and down, and that creates a lot of friction on the part that you're trying to pull out of there. So when you're designing parts to be injection molded or just molded in general, you need to have what is known as a draft angle. So this plane kind of needs to be angled inward. But depending on how thick your mold is and what your material is, you know, if it was a soft material or a material that shrinks significantly when it cools, it might separate away from those walls on the outside and be able to pull up nicely. But it's a kind of case by case. But in general, you want to have a draft angle on your molds. Does that make sense, Robert?
Oh yeah, no. Yeah, it makes big sense. But boy, they must have just spent months drawing up molds before computers.
Yeah, seriously. Yeah. Or like trying to make them from a physical item. Like you'd probably made molds from scratch from your physical item beforehand. Like you'd carve I think, you know, for old molds that they would use for like making the cast iron stuff that make up for like legs of machinery, they actually made those legs out of like plywood or wood, and then you would press those into a sand mold, and then you would remove your wood piece, and then you'd have the depression left in your sand mold. And that's how they made a lot of those like cast iron wheels and like cast iron legs and things for tools and machinery. So, yeah.
Excellent.
All right, cool. Good question. Thank you. And so that's it. We'll be done with this project this week then. And next week we will start something new and shiny. I'm not sure what that's going to be. So if anybody has suggestions, and here now if I want to turn all of my other bodies on, if I right click on the component or the thing that I isolated, I can choose to unisolate it as well. So that's kind of an important little pro tip there. And now all my bodies are back. So yeah, we'll start a new project next week. If anybody has suggestions, you can find me around the space, or send me an email, or leave a comment on YouTube, and I will read things and take them under advisement.
What is your email?
I will give you my email offline, so it's not in the recording. But we'll see you next week.
Thank you,
Thanks a
both.
lot.